Chapter 4 Heat, Class 7th. Temperature. We are very often use the words hot and cold. It is quite cold today. My coffee is still very hot. Water in this lake is ice cold. But how do we come to know whether something is hot or cold? Something feels hot when touched while other feels cold. So our sense of touch tells us whether a thing is hot or cold. But does it always gives an accurate result? Let us try to find out with the help of an activity. Here, the activity shows that our sense of touch is not very reliable way to know whether an object is hot or cold. So, how do we know for sure whether an object is hot or cold? Or how hot or cold an object is? Take three water tubs and label them A, B, and C. Pour warm water in A, ice cool water in B, and normal tap water in C. Dip your right hand in your tub A and your left hand in tub B for 2 minutes. Now remove your hands from tubs A and B. Dip them simultaneously in tub C. Observation. While your right hand feels the water is cold, left hand feels the water is hot. A point of inference. A sense of touch may not always tell us correctly whether an object is hot or cold. You might have sometimes heard that the weather news, it gives the forecast of how weather of a place is going to be on a particular day. It also forecasts the maximum and minimum temperature of the day. Temperature is a reliable measure of the degree of hotness or coldness of a body. It tells us precisely how hot or cold a body is. The hotter an object is, the higher will be its temperature. We use a device called thermometer to measure temperature. Temperature scales. We use a ruler for measuring length. It has centimeter and inch scale on it to indicate length in centimeter or inch. Similarly, there are three units of temperature: degree Celsius, degree Fahrenheit, and Kelvin. Accordingly, there are three different temperature scales: Celsius scale, Fahrenheit scale, and Kelvin scale. A temperature scale is defined by two fixed points. The difference between the two temperatures is broken down into certain number of divisions. Celsius scale. Celsius scale, the most commonly used scale for measuring temperature, was developed by Anders Celsius. This scale uses 0 degrees Celsius as the melting point of water and 100 degrees Celsius as the boiling point of water. Between 0 degrees Celsius and 100 degrees Celsius, the scale is divided into 100 equal parts. Fahrenheit scale. Fahrenheit scale was developed by Gabriel Fahrenheit. On this scale, the freezing point of water is 32 degree Fahrenheit and the boiling point is 212 degree Fahrenheit. Between 32 degree Fahrenheit and 212 degree Fahrenheit, the scale is divided into 180 equal parts. Kelvin scale. Kelvin scale was invented by Lord Kelvin. It is used mostly by scientists in laboratories all over the world. On this scale, the freezing point of water is 273 Kelvin and the boiling point is 373 Kelvin. The degree sign is not used in the Kelvin scale. Kelvin is also the SI unit of temperature. Interconversion between scale. Using the following relationship, the temperature scale can be easily converted from one to another. Let us see the first relationship between degree Celsius and Kelvin scale. Celsius plus 273 equal to Kelvin. This is the first relationship. Second, relationship between Fahrenheit scale and degree Celsius scale. F equal to 9 upon 5 multiplied with C plus 32. Types of thermometers. There are three commonly used thermometers. Clinical thermometer. The thermometer used to measure human body temperature is known as clinical thermometer. A clinical thermometer is made up of long and narrow glass tube. One end of this tube is sealed and other end has a glass bulb filled with mercury. The normal body temperature of a healthy person is 37 degrees Celsius or 98.6 degree Fahrenheit. If a person has a fever, the temperature goes up. However, it never goes above 42 degrees Celsius or below 35 degrees Celsius. So the range of a clinical thermometer is from 35 degrees Celsius to 42 degrees Celsius or 94 degree Fahrenheit to 108 degree Fahrenheit. A clinical thermometer has a special feature, a kink or a constriction in the glass tube just above the mercury bulb. This kink prevents immediate backflow of the mercury from the tube of the bulb, thus allowing us to read the temperature conveniently. This is the reason why we give a jerk to the thermometer before taking a new reading. The jerk positions the mercury below the kink in the bulb. Laboratory thermometer. Laboratory thermometers are used in laboratories for performing experiments. Such thermometers can measure temperature of hot objects such as boiling water or cold objects such as ice. The range of laboratory thermometers varies. However, commonly used laboratory thermometers have a range from -0 degrees Celsius to 110 degrees Celsius. While using a laboratory thermometer, the following precautions should be taken. It should be washed before and after use. It should be held in vertical position. The thermometer bulb should be dipped in the substance in the vessel and should not touch the sides or base of the vessel. Our eyes should be at the level of mercury while reading the temperature. The temperature should be noted while the thermometer is still in contact with the object and not when it is removed. The mercury in the thermometer is toxic in nature. Hence, the thermometer should be handled carefully so that the bulb does not break. Why is mercury used in thermometers? In most thermometers, mercury is used for the following reason. It expands equally for every degree and rise in temperature. It does not stick to the walls of the glass. Its boiling point is very high, that is 357 degrees Celsius, and melting point is very low, that is minus 38.83 degrees Celsius. Therefore, it can be used to measure a wide range of temperature. Mercury is shiny, which make it easily visible through the glass. Digital thermometer. A known fact that the mercury is toxic in nature. For this reason, digital thermometers are widely used nowadays. A digital thermometer does not contain mercury. It has a plastic body and is easy to wash and is easy to use and provides accurate reading in the form of digital display. Heat. Give reason for the following. An ice cube melts when it is taken out of the freezer and left in the open. A hot cup of coffee left in the open cools after some time. Before trying to answer the above questions, let us learn what the heat is. When two bodies at different temperature are brought together, an energy transfer takes place between them. This transfer or flow of energy is called heat energy or simply heat. It always flows from hotter body to the colder body. So we can say that heat is in the form of energy that flows from a body at higher temperature to a body at lower temperature. The heat flow results in an increase of temperature of the colder body and a decrease in temperature of the hotter body. The heat flow continues till both the bodies reach the same temperature. Let us now try to answer the above questions. We know that the temperature of an ice cube is lower than that of its surrounding. So, heat flows from the surrounding to the ice cube. As a result, the ice cube melts. On the other hand, the temperature of a hot coffee is higher than that of the surroundings. So, heat flows from the hot coffee to the surroundings. As a result, the hot coffee gets cold. Units of heat. The commonly used units of heat are joule and calorie. Joule is the SI unit of heat. Effects of heat. It results in increase in temperature. When we heat water, it gets warm and its temperature increases. It may result in a change of state. Put some ice cubes in a beaker and heat it. The ice cubes melts to form water. There is no change in temperature unless all the ice cubes have been changed into water. This is because all the heat is used in changing its state from solid to liquid. Similarly, water starts boiling, it converts them into steam. It causes things to expand. Heat gives the particles of a substance more energy, which enables them to move faster and away from one another. Thus take more space and increase the volume of substance. This is called thermal expansion. The degree of expansion depends on the substance. Expansion in solids. The particles of a solid are tightly packed and cannot move about freely. When a solid is heated, its particles gain energy, they start vibrating faster and move a little faster, resulting in expansion of the solid. Example of expansion in solids. You might have seen gaps in rail tracks where two sections are joined. This is done to accommodate the expansion of metal tracks during summer. When you pour hot tea in a thick glass tumbler, it breaks. This is because the hot liquid expands the inner surface of the glass tumbler. The outer surface of the tumbler does not expand much, resulting in a crack. When a lid a bottle is closely tight, you put it in a warm water. The lid expands on coming in contact with the hot water and opens easily. Expansion in liquids. In liquid, the particles are less tightly packed. On being heated, they vibrate more vigorously. They move much further apart than the solids. For the given rise in temperature, a liquid will expand more than a solid. Example of expansion in liquids. When a thermometer is put in contact with a hot body, the mercury inside it expands and rises up. The new level of mercury indicates the temperature of the body. Liquid such as milk overflow on heating. Expansion in gases. In the gas, the particles are loosely packed. When heated, they vibrate much more vigorously and move much farther apart. Gases expand the most on heating. Example of expansion in gases. When you part in a blown up balloon in the sun, the air inside it expands. This causes the balloon to grow bigger. Methods of heat transfer in which heat transfer can take place: conduction, convection, and radiation. Conduction. Conduction takes place in solids. What happens when we heat one end of the metal rod? Let us try to understand what is happening inside a solid metal rod. We know that the particles in a solid are tightly packed. They cannot move around freely but can vibrate about a fixed position. Let us see an activity to observe the effect of heat on nails stuck on a metal rod. Take a metal rod using wax, stick some nails along the length of the rod at equal distance. Clamp the rod to stand. Heat the other end of the rod. Observe the order in which the nails fall. The nails start to fall as the wax that stuck them to the rod metals. The nails start to fall as the wax that stuck them to the rod melts. The nail nearest to the flame fall down first, followed by the one next to it, and so on. The nail other end of the rod is last one to fall. What inference we are getting? The heat from the flame is traveling along the rod from one end to the other. When we heat one end of the metal rod, the particles of the rod at this end start vibrating faster. These faster moving particles collide with their neighboring particles and pass on some of their energy to them. These neighboring particles thus start moving faster. They in turn pass on their energy to the particles further away from the flame. This process and each particle keep transferring the energy to the next particle while vibrating at its original position. Thus, heat is transferred from one end of the rod to the other without actual movement of the particles. This way of heat transfer is called conduction. Condition necessary for conduction of heat. The condition necessary for heat to be conducted are as follows. The two bodies should be in solid state. The two bodies should be in contact or touch with each other. Their temperatures should be different. Conductors and insulator. Do all materials conduct heat in the same way? Let us find out. An activity here to observe the rate of heat transfer in different materials. Method. Pour hot water in a beaker. Take stick of wood, metal, plastic and glass. Dip all the sticks in the hot water. Record your observation. Metal stick get hot fastest. Heat passes through different materials at different rates. All materials do not conduct heat equally well. Depending on the ability to conduct heat, substances can be classified as conductors and insulators. Substances through which heat can easily pass are called good conductors of heat or simply conductors. Most metals are good conductor of heat. This is why they are used for making cooking utensils, heating rods and so on. Metals have free moving electrons. These electrons can move easily from one end of the substance to other, carrying heat along with them. This is the reason why metals are such conductors of heat. Silver is the best conductor of heat. Substances through which heat does not flow easily are called bad conductors of heat or insulators. Plastic, wood, glass, air, paper, cloth, fur, rubber, bakelite are insulators. Wood and bakelite are used in making handles of cooking utensils to protect our hands from the heat while cooking because they are good insulators. Quilts and woolen clothes are fluffy and trap air in the spaces present in their fibers. Air, being a bad conductor of heat, does not allow our body heat to escape to the surrounding and keeps our body warm. Convection. Liquids and gases are not very good conductors of heat. So, how do they heat? Let us understand with the help of an activity. To observe convection, fill the beaker with water. Gently place a few crystals of potassium permanganate at the bottom of the beaker and let it settle down. Put the beaker over a candle flame. Record your observation. A stream of colored water rises up in the beaker. The colored stream then moves down through the sides of the beaker. Explanation: when the beaker is kept on a flame, the water is in contact with the bottom of the beaker gets warm. As the hot water is lighter than cold water, it rises up to the surface. Water from the sides move to take its place. Meanwhile, the hot liquid at the surface becomes too cool, it again sinks to the bottom. This movement sets up a circulating streams of hot and cold water known as convection current. This results in heating the entire volume of water in the beaker. In this activity, heat is transferred from the bottom to the top through the actual movement of water molecules. This method, in which the heat is transferred by actual movement of the particles of a substance, is called convection. This method of heat transfers occurs in liquid and gases. It is because in liquids and gases the molecules are less densely packed and are free to move. Sea breeze and land breeze. Sea breeze and land breeze that blow near the coastal areas are examples of convection currents in gases. The coastal areas usually experience the cool breeze blowing from sea to land during the day. The direction of breeze gets reversed during night. How does this happen? To understand this, let us move to the coastal area like Goa. During the day, the land heats up much faster than sea water. So air above the land surface gets warmer and rises up. The cool air above the sea surface moves towards land to fill the space emptied by the rising warm air. This flow of cool air from the sea towards the land is called sea breeze. At night, the land cools much faster than the sea water. So air above the land surface is cooler than the air above the sea. The warm air above the sea rises up and the cool air above the land surface moves towards the sea to fill the space emptied by the rising warm air. This flow of air from the land towards the sea is called land breeze. Application of convection. Convection has a numerous application in our everyday life. Some of the applications are as follows. Room heaters are placed on the floor of a room or at lower level. Heater warms the air near the floor. When the warm air rises upwards, the cool air sinks to the floor and fills the empty space. This results in effective heating of the room. Air conditioners are fitted at a higher level in the room. This cools the air, which then sinks towards the floor. The warm air near the floor rises upwards. This process continues and results in effective cooling of the room. Exhaust fans are fitted near the ceiling of the kitchen. This ensures that escape of hot air and gases that rises up since they are lighter. Radiation. The method of conduction and convection requires a medium for heat to flow. The molecules of the body play an important role in these processes. However, there is another mode of heat transfer called radiation, by which the heat from the sun reaches to us. In this method, heat travels in the form of electromagnetic waves. The mode does not require any medium for heat to flow and can take place in vacuum. Thus, radiation is a process of heat transfer from hot body to cold body without the involvement of any medium. The energy involved in this process is called radiant energy. Radiation does not need any medium. It takes place in air and water as well. Since electromagnetic waves travel with the speed of light, radiation is the fastest method of heat transfer. When we sit near a fire, the heat from the flame reaches our body by the process of radiation. Objects, solid, liquid, or gas, emit radiant energy. When radiant energy falls on another object, it is partially absorbed and partially reflected. The amount of heat absorbed or radiated depends on the nature and the color of the object. Dark color. Application of radiation. Radiation find applications in many of our day-to-day life situations. During summers, we feel comfortable wearing light-colored clothes. In winters, wearing dark-colored clothes keeps our body warm. This is because light colors are poor absorber of heat and dark colors are good absorber. In cold and hilly areas, the outer walls and roofs are usually painted dark to keep the houses warm. In factories, the roofs are painted shiny silver to reduce the loss of heat in winters and increase the radiation of heat in summers, thus keeping the inside temperature moderate. In room heaters, the reflectors behind the heating coil are shiny, silvery, and polished so that the heat can be radiated to the maximum extent. Also, thank you.